In this proof, our given is that angle A and angle B are right angles. So if angle A is a right angle, that means its measure is 90 degrees. So the measure of angle A is 90 degrees, and the measure of angle B is 90 degrees. I can put these in the same step because they are independent statements. They're not dependent on each other, and they both have the same justification, which is the definition of a right angle. Definition of right angle. Okay, I have measure of angle A is equal to 90. The measure of angle B is equal to 90. And so now I can say measure of angle A is equal to the measure of angle B by the, I use 3 colors. 3 starts with the letter T. T for transitive. Transitive property. And then I can go ahead and switch these angles from being equal to congruent. I just drop the measures. I can switch them from an equal sign to a congruent symbol, because if their measures are equal, then they're congruent by the definition of congruent angles. Yay! We're done. That was a nice, short, and sweet one. Next one is given that angle 1 is congruent to angle 2. We are trying to prove, that FB is bisecting angle AFC. So I'm going to go look at my figure, my diagram, and I notice immediately, jumps out at me, that angle 1 and angle 3 are vertical angles. So I'm going to go put that they're congruent. Oh my gosh, my touchscreen hates me. This seems to be a common theme in all of my videos, how my touchscreen is annoying. So angle 1 should be congruent to angle 3. That is the vertical angles theorem. When I have vertical angles, they are congruent to each other by the vertical angle theorem. And so I have angle 1, angle 2, and angle 3. I have 3 colors. 3 start with the letter T. T for transitive. So I can say angle 2 is congruent to angle 3 by the transitive property. Again, I'm so sorry, my handwriting is horrendous. Okay, so if 2 and 3 are congruent, that means that this ray is bisecting that angle. It's cutting that angle into 2 congruent halves. So if those 2 angles are congruent, that means FB must be a bisector. So FB bisects angle AFC. That's the definition of an angle bisector. So definition of an angle bisector works in both directions. If I tell you it's a bisector, you can say that the angles are congruent, or vice versa. If the angles are congruent, if 2 and 3 are congruent, those 2 angles are congruent, then that means that that ray has to be a bisector. So it's true in both directions because it is a definition.